Hey everyone. I wanted to look at another question and the homework, and this is a question about R squared, which is a measure of how well the data are actually fitting their regression line. Because we can take data and we can slap a regression line on it, but is it actually a good line? R squared is going to tell us some facts about how well that line fits the data. So I'm using one of the data sets from another example that I had given, and it was about well-being index and commute time. And we had computed a regression line, and I had pointed out what R squared was, but I didn't interpret it. Before I interpret R squared, I want to show you a picture of the data. So here we have the well-being index score, that's our Y value. Our commute time is X. And we notice that the points follow a negative linear trend. So as commute time goes up, the well-being score is actually going down. So that maybe quality of life measure is getting less and less the further you have to travel to and from work. So we want to look at the line, which is in red, and then the data points and say, do these data points seem like they fit the line pretty well? Are the points pretty close to the line? If you look at that, give it a moment. What do you think? Does the line fit the data pretty well? Is it a pretty good predictor of Y if you're given X? So think about it a minute. All right, now that you have had a chance to think about this, and if you still need to pause and think about it, go ahead and do that. When I look at these data points, I notice that they're pretty close to the line vertically. So that's my measure of closeness, not a side to side measure, it's vertical because the the points that create a line are predicted Y values. The blue points are actual Y values. So I'm looking at how close the predicted value Y hat is to the actual Y. This is very close. It looks like my data point is slightly below the line, so the predicted value is slightly higher than actual. Here's another data point. It's actually higher than what is predicted. The predicted well-being index score is a point here on this line, a little bit below 64, but then the actual well-being score seems to be 63.9. So it seems to me like there's a pretty strong relationship between commute time and the well-being index score. And we can also see that by the value of the correlation, negative 0.99. So that's very strong negative relationship. And when I square negative 0.99343985, I get R squared, 0.98692274. There's a lot of decimal places, but really we just need like a few decimal places. So 0.98, we want to turn that into a percentage. So we could say 98.7%. So remember that number, 98.7. And I'm going to go back to this regression line and create a sentence that is explaining what happens in this relationship. 98.7 means 98.7% of the variation, so the wiggle factor of the Y values, is explained by commute time. So we know that there's a pretty strong relationship between commute time and well-being index. So this wiggle, because the points are not exactly on the line, some are, but there's a little bit of variation. It means that there's some other variables out there that are affecting someone's well-being score that we didn't study. So we only studied commute time. There's some other variable out there which is going to affect your well-being score. And it accounts for the balance of the 100% of the data. So if our R squared was 98.7, that means 1.3% of this total variation that we can calculate is explained by other variables that we didn't study. Since 98.7 is really close to 100, that is a really strong, a lot of strong evidence that our commute time is affecting well-being score. Now, did we do an experiment to decide that commute time is causing well-being index score to increase or to decrease, well, we can't say there's causation unless we do an experiment. So right now we can just say, hey, there's this relationship that we notice, and we have to leave it at that. So to recap, when we talk about R squared, the R squared measures the proportion of total variation in response variable, y, that is explained by the least squares regression line. So when we choose the option here, we are looking at the coefficient of determination. That is the word that means R squared. It's the long way of saying R squared, coefficient of determination. There we go. So proportion of variation, and by proportion, we're meaning percent, 98.7% of the variation in well-being score is explained by the least squares regression line. And then I often say least squares regression line on commute time because that was the variable that was explaining index score. If you have any questions, let me know.